Hey Corksters, my name is Joyce, inventor and entrepreneur, and this week I need to change up the format on you. What I mean by that is typically you hit play, I say hello, and then I present the benefits and features of my proposed product this week, or for that week. The reason that process will not work today is because the product that I'm presenting today I have been working on for over 10 years. I've gone back and forth, on and off, and finally, I believe that this product is at a point where I can share it with you, and quickly thereafter, it can go on into the market as its own product category in a well-established field. And I call the product the Ultimate Framing Hammer. Now, the reason that I cannot just jump into the final rendered images is that if you by chance fall into the category of someone in the viewing audience today who is not up to speed on all the patterns and trends of framing hammers on the market today, then I need to take a step back and share with you my creative process before you can fully understand and appreciate the gravity and scope of what I am proposing today. Invention has been described as seeing what everyone else has seen and thinking what no one else has thought. In today's presentation, I will share with you 4 hammers that have inspired my final design. And by sharing this portion of my creative process with you, you will have been able to see what I saw, think what I thought, and at that point, you will be fully equipped to provide me with your comments and feedback. On a final note, today's presentation, today's extended length presentation, I'm not just creating it for the consumer audience who will vote, comment, and rate my submission. I'm creating this video for every designer and engineer who will ever work on this project. For you designers and engineers watching, do not take my final rendered images as the departure point. Take this video as your departure point. You may be familiar with the saying, seek not to follow in other men's footsteps, rather seek what they sought. This video will allow you to do just that. So let's get started.
If you've ever had a brilliant idea and then you present it to someone and they say, that's ridiculous, you guys know better than most that oftentimes the difference between a brilliant idea and a ridiculous idea is the successful execution of the industrial design. So let's do what we do best and let's design the ultimate framing hammer together. If you were to shop at Home Depot or Lowe's, you would know that framing hammers today are retailing for about $20 to $50. The best, or considered the best, framing hammer on the market today is made by Stiletto Tools. It's manufactured out of titanium instead of steel, and it retails for between $200 and $250. The framing hammer design that I'm proposing should be better in its functional performance than the Stiletto hammer, and it should retail for about $100. If you go ahead and look down at the table here in front of me, you will see that I have 4 hammers. Now I have 1 patentable game-changing innovation, and then from these 4 hammers I have a total of 8 features that I want to extract and adapt into the final design. If we start over here with this S-wing hammer, if there were one hammer design that we would call it our primary design departure point, this is the one. This is a pretty great hammer as it is. It's called the S-wing weight forward by design, and you will notice that it has a curve built into it. The steel comes and runs in one piece, and this is the overstrike collar. And then you'll also notice that it has a square head. The reason I'm going to want to go ahead with the square head is that not only could that be considered quirky, but also if we're delegating this to be the framing hammer, then when you're framing, that doesn't just mean hitting nails, but also beating 2x4s into submission and squaring them up, and therefore a square edge is more ideal than the round edge. So looking here at the weight forward design, just the way the hammer's balanced, boom, it strikes. It's not taking a lot out of your forearm, boom, it strikes. Let's go to the table again. Now let's imagine there's a nail there, we've just hooked in, and we want to pull it out. Trying to pull the nail out, not quite working. Now notice right there, there's a little hole, almost as if there should be a pivot point, right? Well, imagine this. Follow down to about here, and there's going to be a handle here. This is the game-changing patentable innovation, and this handle pulls out, comes to the top, and now we've got out a 2-foot lever arm. And as we grab that, boom, pull that nail right out of the table, come back, fold it back in, and that's not just amazing because now we can pull nails with more leverage. And again, you guys are the engineers. I remember that torque equals R sine theta. I don't remember how to calculate that. So if you can tell me just how much more awesome and high leverage that is, I'd be curious to know. Anyway, moving on, here the handle's back in, and if we're looking up the side, there's going to be a seam, and that's going to ride to about there. And so while the dimensions of this hammer will remain about the same, there's not going to be any fiberglass. So this is going to be all one piece of steel. There's going to be a convex shape on this face, and then coming from this side it would be concave, so that that piece folding in fits inside of it. Now, because we're going to have a piece of steel on the front wrapped in rubber, a piece of steel on the back wrapped in rubber, and then the hand closing in on the final design, the reason that this should be better than the Stiletto Tools design is that yes, it's made of steel, but due to the fact that we've got weight forward by design and a split in between the handle itself, which should probably decrease the vibration by 75% if weight forward design decreases vibration by 50%. And so with that in mind, you're going to see the split right up the center. Right about there, there'll be a enunciated handle of sorts that you can pull out, and it will look great. We can follow up with questions later, but let's move on to the next hammer benefits, features that we want to extract and adapt. You'll notice on this S-wing hammer they have what's called the hammer tooth, and what this is for is that with more and more houses being framed with pneumatic nailing, the feature of this hook is that you can take a 2x4, grab it with the claw and the hammer tooth, or the hook as it's called, and then with a pneumatic nailer, hands safe and free, drive those nails, and this hammer did the work. It's also great for digging into a crooked stud wall and straightening it out, or digging in, lifting, framing. So again, this little hammer tooth feature, it's worth its accent. And the way that's going to look is that if we come back to our primary departure point design, when that curve comes up and we make this little handle here, it's going to stick out that same amount, and you guys can just measure that point and that point to create this condition with that condition. So again, the hammer tooth now becomes the handle. Moving on to our third hammer of choice. Again, you'll see that it's all one steel piece construction, but primarily what we're looking to extract and adapt on this one is, if you are not familiar with this feature, this is the ability to take a 16 penny or 8 penny nail, and it's got a magnet up top, and you set the nail in there, and now if you're on a ladder framing windows or just something higher than you can reach up and get that started and then finish it off. So from this hammer, we're just taking that magnetic nail start. We started over here with the primary design departure point. We're ending with just some really important features. This is the hammer that I've used for the last 10 years. I've built an entire house with this back when I was in high school. And I want you to take a look at these two rubber handles here. Notice how this one has no texture, has next to no flare, and that's a mistake. When your hands get sweaty, this really starts to move on you. And so the design application from this hammer that I want you to put into our ultimate framing hammer is that we want the ribbing and we want the flare in the center. And then that ribbing only comes to about that halfway point, and then on the back we've got a different texturing, and that's because it creates less calluses with this texturing on the back. So whether or not we can use this thumb indent, that's to be seen. Probably not, but it is handy when I've used it. And then finally, what may be one of the biggest selling points of framing hammers to framing carpenters is that if you imagine this hammer, here it is in my tool belt, it's hanging there. Something that framing carpenters love is that a hammer should be an extension of them. And that means that I can come and grab, my fingers are on it, and without looking, without thinking, I can just come, flip, swing back, down, and drop in. Out, flip it around, in, out, flip it around, in, out. It's just a perfect extension of me. Now you will notice, coming back to our original hammer design, move these here. A design flaw that they have is that this extra, half inch of material here, so you can get your fingers around it, you can't do that here. You slip right off, and there is no opportunity right now for me to successfully twirl this around without throwing it out the window. So, as we seek to get the cool factor of this continual piece of steel with overstrike protection, with square waffle face, simply take the same distance from claw to face, put that into here, and make sure that there's enough of a dip that we get this same cycle for the index finger to rotate around the pivot.
So without further ado, enjoy the slideshow of my proposed design, then comment below with your feedback, including how you think we can improve this design. Thank you.